Let's read the question together. Figure 1 shows the equipment that a student used to investigate the rate of decomposition of hydrogen peroxide solution with and without a catalyst. Let's have a look at figure 1. We can see it here. We've got a conical flask and we've got the hydrogen peroxide solution in there. That would need to be controlled in terms of its volume and concentration that is actually in the container here in order that we can compare between with a catalyst and without a catalyst. In this particular diagram, we can see the catalyst has been added, manganese 4 oxide. Remember, the 4 tells me what charge is on the manganese ion. So this is Mn4+, because the manganese is a metal, so it must be a positive ion, and the number 4 tells me what charge it will be. Now, at the top of the conical flask, we can see a bung, and in the centre of a bung is a hole. We've got a delivery tube connecting this, which is called the gas syringe. The gas syringe would be clamped in position so that it's nice and safe, and the point of this is if a gas is made, it goes through the delivery tube into the gas syringe and it pushes out the plunger, and you can measure where the plunger is, the volume of gas that's being produced. So what key information has the examiner given us? They've given us the diagram. That is very important. And we're investigating the rate, the speed of the decomposition of hydrogen peroxide. And we're looking at it with and without a catalyst. Part A. Oxygen and water are the products of this reaction. Describe how the rate of reaction could be monitored. So what's the command word? The command word is describe. That means state simply. We don't need to say why. And what other information have they given us? They've told us that oxygen and water are the products of this reaction. And we need to describe how the rate of reaction can be monitored. So, oxygen is a gas under room temperature and pressure. So that gas is what we could use to monitor this reaction. So let's start penning our answer. We can measure the volume of gas. We can actually say oxygen if you like, and that's 1 mark, released in a given time. That will be a 2nd mark. Measured on the scale of the gas syringe. So we're talking about what piece of equipment we're using. So 1 mark for saying that we're measuring the volume of gas released, 1 mark for saying in a given time, and 1 mark for saying how we're measuring it, which is on the scale on the gas syringe. Part B. The student found out that 100 cubic centimetres of gas was made in 20 seconds with a catalyst. Calculate the mean rate of the reaction and give the units. So, what's the command word? The command word is calculate. What other information have they given us? We've got 100 cubic centimetres of gas and we've made that in 20 seconds, and that was when the catalyst was present. We need to calculate the mean rate of reaction, and crucially, we need to give the units. Now, mean here doesn't mean angry. It's a type of average. Okay, so it's the average speed the reaction happened over that 20 seconds. So it's going to be how much gas, which in this case is 100 cubic centimetres, and we're going to divide it by the time it took, which in this case is 20 seconds. So therefore, the answer is 5. But 5 what? We have to put the units. And it's 5 centimetres cubed, which that comes from, per, that's what the slash means, per second.